Dr. T's Research Methods Basics video, we'll be talking about relationships between variables, and this is really the beginning of what we call bivariate analysis. What we're most interested in understanding in social science research, criminology, criminal justice, and most other sciences is relationships between at least two variables. Our x variable, we're going to refer to the independent variable as our x variable, independent variable, and our y variable, well, that's our dependent variable, and our dependent variable you can also think of as really the outcome variable. This is the variable that really we are most interested in understanding. And often it's because we want to know how our independent variable affects the dependent or our outcome variable. Before we get too far, I want to go ahead and address what I think a lot of students kind of hesitate with, and that is understanding the difference between variables as far as being independent or dependent in their research. So let's go ahead and we're going to take a look at a bunch of graphs in this video, because the easiest way to understand this is to just kind of practice through some examples. Now, our x-axis is the horizontal axis, and our y variable is on the y vertical axis. Now, the y variable is always our dependent variable, and the x variable is always our independent variable. And one way to remember, if you were ever asked to graph relationships, one way to remember which axis is the dependent and which is the independent is to think of this kind of, that's how I think of these concepts, right? The vertical axis, the y-axis, I like to picture it as a wall. And the x-axis, this is the foundation. The foundation is holding the wall up, right? If I accidentally broke apart a piece of this foundation, then my wall would fall over, right? Why? Because it depends on that foundation. Let's think through these things with some examples that we're probably familiar with in criminology, criminal justice. Let's say that I'm most interested in understanding, let's say, the relationship between the percent poverty in a city and that city's crime rate. So let's do crime rate. What I'm most interested in knowing about is what's going on with the crime rate, right? And I think that percent poverty may have something to do with it. Well, if you imagine on this y-axis that the crime rates are measured, say, let's say they're 100 per 1,000, okay, of the population. And the percent poverty variable we get from the US Census or the American Community Survey, and it goes something like this: 20%, 30, 40, 50, and 60. All right, well then I take a look at, say, I don't know, 80 cities across the United States, and for every single one of those cities, I decide to plot out where their crime rate is in relation to the percent poverty of that city. So I would look at a city and I'd say, okay, this city has, say, 22% poverty, and man, their crime rate is way down here, okay? And I do this for all the cities, And I would probably see a relationship that looks something like that. Well, if I look at this kind of overall, then what I see is a relationship that's really kind of increasing from left to right, where the cities with the lowest amount of poverty also have the lowest amount of crime, and the cities with the higher amounts of poverty have the higher crime rates. I would say that I have a positive relationship because the X, my percent poverty, is increasing. At the same time, my Y, my crime rate, the one I'm most interested in understanding, is also increasing. So I would have a positive relationship between the percent poverty of a city and that city's crime rate. Now, we're not talking about cause, right? I cannot say that the percent poverty in a city causes a higher crime rate. There can be a multitude of things occurring. So I can't say it's causal, but I can say that there is a positive relationship. Now let's do another one. Let's say we're really interested in better understanding a state prison population. And we want to know maybe if there's a relationship between the crime rate. Let's do that one. The crime rate of a state and the size of the state prison population. Well, we could kind of imagine on this y-axis here that the state prison population is measured in thousands. And that the crime rate, again, state level, measured probably per 10,000. So maybe we start with, I don't know, say 600 per 10,000. It's kind of weird, but okay. And then we have 1,200 per 10,000, and it just goes up. And then I do the same thing. I take a look at a whole bunch of different states, and I plot their prison population relative to that state's crime rate. And what I find is, kind of similar to the first one, as the crime rate increases, although it would probably level out a little bit here, as the crime rate increases, so does the state prison population. Makes some intuitive sense, right? And again, we have another positive relationship. As X is increasing, Y is also increasing. Looking at another example, let's say we have interested in still understanding, let's say this time we're interested in understanding property crime. And we're wondering if the number of police per 10,000 of a city's population has anything to do with that city's property crime rate. All right, so we take a look at a whole bunch of cities, and their property crime rates would probably be per 10,000. And we take a look at officers, and we're looking at, let's see, number of police officers per 10,000. So, I don't know, let's say 15, 30. Okay. Well, if we look at this and we plot out a whole bunch of different cities, more than likely we will find something kind of like this, where across all of the cities we examine, it appears as if there's a relationship between the number of police per 10,000 people and that city's property crime rate. And it looks like This is a pretty clear linear relationship here. And it's going down from left to right. Our X is increasing as our Y is decreasing. This is a negative relationship. But it sounds positive, doesn't it? Because crime is going down. Well, in statistics, when one variable moves one direction and the other moves in the opposite, it's a negative relationship, no matter how good it is for the city. Let's try another one. This time we're interested in trying to figure out, we're most interested in understanding recidivism. People returning to jail or prison for committing a crime after they've been punished for committing a similar or the same crime. We're interested in understanding recidivism, and we think that just maybe the number of social service programs in a city that are geared towards reducing recidivism have something to do with changes that we see in recidivism. So we take a look at a whole bunch of cities or a whole bunch of states, and we're looking at how many social service programs that are focused on decreasing recidivism are in a city or a state. And then we look at recidivism of the population known to police, and that's probably most easily a rate, and it's probably per 100 people. So something like this. And if we plot it out city by city, we would see probably something a little bit like this. Again, as the number of social services programs geared towards reducing recidivism in a city increases, recidivism is decreasing. No matter how positive that sounds, we have our X increasing as our Y is decreasing, and so we have a negative relationship. The only other two things you need to be on the lookout for when you're taking a look at relationships between your independent and your dependent variable. The first is that you could have a scatter plot, doesn't matter your variables, that end up looking a bit like this. Well, there's nothing clear in that pattern. So that means there's no relationship, and you should stop with your analysis right there. So looking at relationships between X and Y often tell us if we need to move further into testing any hypotheses or answering any research questions. The other type of relationship, and it can go in a couple of different directions, but it could look something like this. This type of relationship where you see not just a clear positive or negative, but you have kind of a tipping point at some point. This is called a curvilinear relationship. Definitely worth investigating. But it's neither positive nor negative, it's curvilinear. There's something that kind of tips that Y, that dependent variable. It's on a trajectory going up and suddenly starts going down. We have a clear curve, worth investigating, curvilinear. It could also be shaped the other way. So it could also kind of go in this upside down view.